reps before recording. It will only be available for 7 days on the platform. So your colleagues those who are not joining, warn them because you'll not be there forever. All right. All right. Okay, so this is my email address. Now I told the level 300 something. Let me also, I believe the class reps are here. Christian, Theophilus, is it Theophilus? Anthony, sorry. Christian, Anthony, and the other guy, I've forgotten the name. All right. So please, I told the level 300 that if any of the students they have a problem or they have any challenge or any issue, the first thing is they need to get in touch with the class reps before anybody calls me. Don't call me. Don't send me a WhatsApp message. I will not mind you. Please talk to the class reps. They will get in touch with me, and if I'm not, or if whatever they are trying to explain is not clear, then I will ask them to let you call me. Then I can address the problem from there. Now, it's not that I'm hiding myself or I'm trying to prevent students from reaching out to me. The reason, or one thing students don't like doing is to follow instruction. Students don't like to follow instruction at all. When you tell the student to sit here, the student will try to do the otherwise. That is why I have this, arrangement. Anywhere that I go, if I give the instructions you don't follow, don't come to me. So when I ask you guys to do something, I share video, I share those things. Then I said, follow the video. You need to follow and do accordingly. But if you go and do any other things or you do otherwise, and you see them calling you, sending you messages, audio messages, I won't listen to them. So please pay attention. If you have any challenge, contact the class reps. They will reach out to me. All right. All right. So the course introduction. So I don't know if any of you have basic programming experience, but I know Seth. I don't know if Seth is here. Okay, he's more into this because he was once my mentee. People, is he mentor? Is he mentor, mentee? I'm confused. Yeah, mentees because I mentored them. Okay, so he's one of my mentees. All right, so he's more into the programming stuff. Okay, so we are going to build upon these skills and dive more into medical image processing. Now, I told you guys that in my each and every year, I acquire new skills, I acquire new experience. So it's going to be a little bit challenge for you guys this time. So make sure you sit up. Okay. Somebody said, don't give up. It's going to be tough. That doesn't mean that you should give up. It's going to be tedious. That doesn't mean that you should give up. All right. So there are certain objectives that we are supposed to achieve. Okay, when I'm done. So at least you to do some basic things in Python, describe some applications of machine learning, medical imaging, and also you implement automated algorithm for image processing. So we will be using some of the deep learning algorithms. Okay, one of them that we will talk about is the CNN, the convolutional neural network. We'll dive deeper into it and implement it when I come. So get ready. And also do a little bit of transfer learning, how to transfer one experience or one knowledge or from one problem to another. We'll talk about that. All right. Now, please, the dates, don't pay attention to the dates, but we'll have lectures, we have labs. Now, I'm quite busy nowadays, so that is why we are doing the lectures online so that I can focus on the lab. Okay, the labs, what you see here, we spend how many hours? Almost 3 hours, right? 3 hours. So when I come, I have an arrangement with Professor Nash. We are going to do back to back. Okay, 6 hours continuous, 6 hours continuous. When we start, let's say 7 o'clock, by the time we are done, that will be around 12 o'clock. Then we'll break. Then we start again from 1 all the way to, let's say, 5 or 6. So when I come that arrangement, I'll make it clear before we start. So get ready. Make sure you have a laptop to yourself, and also, yes, a laptop to yourself. And as I said, all the online sessions that we'll do, when we come, we'll be writing quizzes. So maybe 10 minutes of that time we used to write all our quizzes. So get prepared. Okay. So the platforms, Canvas, okay, this is the platform we use to submit our labs, to submit presentation slides, also to submit assignments. Then we also use Kaggle, others also pronounce it Kaggle, but the word is Kaggle. Right, then Google Colab 2 is there, but I like this. The reason I like this is that it is a full platform with the data sets and computing resources, integrated together. So it's one thing. This we have to sometimes upload the data set, which I don't like. So we're using Kaggle for our work. All right, so this is the assessment. Attendance, 50%. Take note of that. That's why I said those of you who are missing the online, it will shock you that I can give 10 for the online, give 5 for the lab attendance. So inform your colleagues. Then assignment also will be 10, quiz 20%. Then lab will be 25. Then final group is going to be 30. The reason why I did this, the first time I came to lecture, some of the students outsmarted me. I made the final project 50%. So they didn't even show up. They didn't even do any homework, the assignment and stuff. So they were able to, pass. So I learned the hard lesson that coming for lectures or going for lectures is also part. Okay, it's also part. So if I make the final project 30, if you don't pass any of these things, don't worry, the project will not save you. So that shows you that you need to put in the effort in all, in terms of attendance, assignment submission, your quizzes, your lab work, and your final project in order for you to get your A, if you really want to get A this time. All right. All right, so these are the things that we'll be doing. We'll talk about introduction to AI. Today's lecture is going to be this, introduction to AI. Then tomorrow, when I come, the lab, we'll talk about this, introduction to Python, and do some basic stuff. Then we'll also learn about fundamentals of AI. Okay, we'll learn about machine learning, deep learning, all sorts of things. Then when I come the lab, we'll talk about, or we'll build a classifier or a regressor. Then lecture 3, we'll talk about medical image processing and analysis with AI. Then when we meet in the lab, we'll be reading DICOM, segmenting, extracting meaningful features, edges, and shapes from medical images. You'll have a case study. That's going to be your lab assignment. Then day 4, we'll talk about the deep learning for medical imaging. So here, the practical exercise is to pick one deep learning library. Okay, then we're using PyTorch, but our main focus is going to be on CNN, convolutional neural network for image classification. We also talk about transfer learning. All right, but we will not go deeper, but I will expose you guys to what is known as transfer learning and pre-trained models too as well. All right, then the last 2, which is day 5 and day 6, right? Yes, day 5 and day 6. Okay, so day 5 and day 6, we'll talk about advanced topics in medical AI. Then, which here we'll talk about image registration fish. I don't know whether you guys are doing it. You've treated it, but you look at it from the angle of artificial intelligence. Then also look at natural language processing. I'll define all these things. I'll expose you guys to some of these things. Then the last thing will be application of AI in healthcare. Now, some of your assignments will be research work, which I'll push you guys seriously to go and research in some of these new emerging stuff. For example, AI-assisted diagnostics, radiomics, and also AI-powered treatment planning, and also emerging AI technology in medical imaging. I will let you guys go and do research and present your finding for you to be graded. All right, so that's what's going to be that. Okay, so that is the introduction to the program or to the course. Any question? If you have any question, please, you can raise your hand. I'll call you. All right, Abdul Rahman Karim, go on. Unmute and speak. Abdul Rahman Karim, unmute and speak. All right, maybe I don't know where it's a mistake. Okay. Now, let me tell you the same thing I told the level 300. You guys are medical imaging, or yes, medical imaging students, which is radiographers and radiologists. Somebody is thinking, so why are we doing all these things? I mean, what is this man trying to tell us? Okay. Please mute yourself, or else tomorrow I will lock all of you. Mute yourself, please. If you are not talking, I'm the one talking. If you want to talk, raise your hand. If you're not talking, you mute yourself and listen. The background is not going to help. The background noise will not help all of us. Or else tomorrow when we meet, I will lock all of you. Okay, so I told the level 300s that a lot, is happening, okay? A lot in medical or healthcare, and even the education we are receiving nowadays, especially those things that we are even doing in Ghana here, most of them are obsolete. That means okay, so most of them are obsolete. Now AI has come to stay. Okay, it's like when
There is another.
It's like when they invented the calculator, they thought that calculator is going to uh, the calculator is going to make students weak. Okay, but it was a tool. All right, and we've all seen how helpful the calculator has been. The same thing with the AI. Most people are scared that the AI is going to make our students weak and they won't learn. No, it's a tool. The AI is a tool. Okay, if you learn how to use it properly, it will make your work efficient and you'll be able to do all sort of things. But over dependence of it on it, that is the issue. So for example, when you're using a calculator and you there, all you do is use a calculator to do everything. You don't even work the thing. Yeah, I'm not done. You don't even work the thing. All you do is use a calculator. That's why what you become weak. The same thing with the AI. It's a tool. Learn how to use it. Learn how to apply it in your area. Now, it's better for you to sacrifice, get the fundamentals right, so that when you are building on it in the near future, it will not be a big issue for you. Or else you pay a huge amount of money for somebody to teach you or to train you. But when you have the fundamentals, building on it becomes quite easier. Who knows, some of you will want to continue education, go and do your master's, go and do your PhD. Now you might need some of these things somewhere, which if you have the fundamentals, building on it becomes far, far more easier. All right, so that is something small I will share. All right, so thank you. Okay, so introduction to AI. My first question, but before I ask, let's go through what is expected of us. So we'll by 10, we should end the session. So we need to know or understand a lot about AI, its evolution, explain how AI has transformed our medical imaging, then the ethical consideration in AI, then what are some of the limitations. Although AI is changing or making, or the hype is a lot, but what are the limitations and also the benefits? All right. So I'm going to create a pool right now. What first comes to mind when you hear the term artificial intelligence? I'm going to create a pool right now. Make sure you type something. It's like asking a question in class. So those who contribute, we score them or we award them. All right. So the same question, I'm typing it. What comes to mind when you hear the term artificial intelligence? Please type your answer in the pool. Okay. The pool, make sure your answer is uh, brief. Don't type a long something long. Okay. All right. So we have 3 minutes to provide answer. Don't type your answer in the chat. Type it in the pool rather. Hmm. Okay, one response. Chat GPT. All right. When is the anytime you talk about AI, it's talking about Chat GPT. Okay. Uh, who else? Artificial intelligence is the means by which computer perform basic things, operations human will use his or her mind to. Okay. You're learning to use of system to perform tasks that typically require human intelligence. Machines thinking like humans. Computers being able to perform advanced tasks. The intelligence is a good intervention to help revolutionize the world, make things automated and simple. I hope you are not typing the answer and sending it to me in Google and some of these browsers and sending the answers to me. All right, the ability to make decisions, solve problems, and learn by a machine. An algorithm that performs advanced tasks, computer programming, when machines are given the ability to think for themselves with preset command to do what humans normally do. Or when machines are given the ability to think for themselves. So intelligence is robotic machine that answers or does what humans do with machines. Out of the 44, I have 22, 25 responses. I see it to be machines doing things that human beings do, that human task, therefore making life easier. AI basically teaches machines how to think like humans and they are faster. Computer system capable of performing tasks human naturally. All right. Okay, so I'll end the poll here. All right, so I've gotten enough from some of you. I believe that you did not post, I mean, type the question in Google for Google to give you the answer and you use your own understanding of what you know about AI. All right, so this term, they keep on hyping it, artificial intelligence, artificial intelligence, artificial intelligence. Now, what is this artificial intelligence? A lot goes into it. We have different branches. We'll talk about it. All right, so we have different branches. We'll talk about it. But before we define the term artificial intelligence, we need to understand what is intelligence. When say someone is intelligent, what is the meaning? Okay, so let's find out another pool to find out the word intelligence. Okay, so when you say someone is intelligent, how will you know that someone is intelligent? Or who is an intelligent person? Okay, so define the term intelligence. Okay, so define the term intelligence. Okay, so this one to type. I'm giving you the same 3 minutes. Please, those who are not muting yourself, mute yourself. You will not do it. Tomorrow, I will lock all of you. I have to be honest. Okay, all you have to do is just you communicate via the pool. Simple instruction, you won't follow. Okay, so what is intelligence? Someone's ability to make decisions and solve problems timely. All right. Someone that can learn and understand. Okay. Oh, sorry. Who else? Ability to solve problems with one's own thinking. So performing tasks that will require additional time and energy. Ability to use the mental power to overcome complex tasks. Kunadu Yadams Sabina, mute yourself, please. Someone who is knowledgeable, ability to make decisions and solve problem timely, intelligence, the ability to learn, understand, apply knowledge to solve problems or adapt to new situations. Someone said ability to reason, solve complex problems, make meaningful outcome, ability to acquire and apply knowledge to solve tasks, showing high level of understanding, someone that can learn and understand. Who else? Ability to genuinely ability to genuinely answer questions simply. Okay, ability to make right choices and solve problems, reason and think critically. The ability to solve problems with, okay. All right, so how many? All right, so more than 32, that is fine. The next question is, can you name any intelligent person you know? So name any intelligent person that you know. Okay, so name any intelligent, just one. Okay, so let me say, name one intelligent person or individual that you know. So name one intelligent person or individual that you know. All right, so start. Let me stop the time. All right, so let's see. Okay, someone was it Marx? Albert Einstein. Who is this? Issue speed. Who is this show speed? John McCarthy. From where? Somebody said myself. Okay. Someone say Enoch. Who is Enoch? Professor Alute. Okay. Samson Bacha. From where? Somebody said Richard Asiamah. Somebody said Mark Zuckerberg. Isaac Newton, Elon Musk. Who is Larry? Okay, the person said I'm Larry is here. Dr. Baumia, the digital man. I see. A couple Collins from where? All right. Bill Gates is into Karl Marx. Wow. Okay. All right. So thank you. At least we know that some people who are intelligent. So those that did not mention, you didn't mention your name. That means you are not intelligent, right? Definitely. Okay. So let's take it like that. Okay. So now that we have a knowledge or idea of when talk about artificial intelligence, what is it? Then also uh, or also what intelligence is. And we know people who are also intelligent in this world. We'll find out if you are intelligent, you yourself. Okay, so before we define what is AI, we need to start from somewhere and understand why AI at all. Why do you have to waste time studying AI? Now, a lot has happened, or a lot is also happening, right, in terms of medical records. Now, when you go to the hospital, hardly will you see a hospital or even a clinic where they will go ask you to write your name in a book and uh, they will ask you to write your name in a book and they will use writings in order to collect your data and all sort of things. Now they are moving a lot of things or digitally, right? So they have a computer system over there that will they'll use it to key in your data and refer you to the doctor and all sort of things. So what is happening? Now, data that we keep collecting at the hospital keeps on increasing. Data that they keep collecting in the hospital keeps on increasing. Now, when you have data, I'm coming, guys, give me a minute. Okay, so data is very, very important. Okay, all AI systems depend on data. The prerequisite of any, not all, but some of the AI systems, okay, they all depends on what? Data. So data is much, much more important. So the rise of electronic medical records, personalized genomics, and lifestyle and health data, the capacity of better and faster analysis of data and trends or AI systems changing, okay, has given AI opportunity to be integrated into our hospitals, okay. But once we have access to patients' data, okay, what
Yeah,
can
but also, yeah, but already, update is a
okay. I on the course na yes.
yeah, sorry.
I'm okay, man. Some much as
Okay. So what's this EMR? They include a lot of information and notes collected by clinicians. And I mean, it all boils down to one thing: data collection or data accumulation. Because when you go to the hospital, they measure your vitals, you take a scan, you go and see the doctor. It is data that keeps on what? Accumulating. Now, somebody or immediately they give birth to a baby boy, okay, when the baby is sick, we take the baby to the hospital. That means the baby's data at the hospital, we can accumulate it over time. And once we have enough data about that baby or that child or that grown up now, that is what we call something personalized genomics or personalized healthcare. So we can treat you based on your data. We are not using generic. Okay. And you know, in your work in the medical field, I learn medical field, they learn along. They are not like, because one of the most difficult thing in this world is human beings are not the same, different features, different characteristics. So it's difficult for you to be able to what, use somebody's data for another person. Okay, but once we have data of a patient, be able to what, prescribe specific uh, drugs, specific treatment for that person. So you see how the data set keeps on accumulating and building in our hospitals. Okay. Now we have these data. What do we do with them? What should we do with them? That is the question we keep asking ourselves. For example, that's a research where you guys will do. We call it radiomics. We have a lot of scan that has been taken at the hospital. What can we get from these imaging or these scans that we have taken? That's the question we need to start asking ourselves. So these are areas that we can get data okay, in a healthcare, so home care, pharmacy, hospital. So guys, if I block you guys tomorrow, I believe it's not my fault, right? So that's what I'll do tomorrow. Tomorrow, when I set the call, I'll make sure I disable all of your my microphone, videos, everything. Then what you do is I just have to pay attention from your end. If you don't pay attention, that'll be your own. Then general practitioners, nursing homes, and telemedicine. These are all areas that we can obtain data from. Okay. So big data and data accumulation, I've already explained it, okay, that when you take any data, we can characterize it using volume and also complexity. Volume and also complexity. Okay.
I used to have them.
All right. So big data is characterized the collection of data that is so large in terms of volume and complexity. Now, when you take these big tech companies like Google and Facebook, they get most of their money from the data they collect from us. So when you're on Facebook, remember you're feeding this company with data and they are getting money from. Google also, when you try to use their system, we leave data over there. Okay. And this data, as I did explain the previous slide, in a hospital, we have about various sectors that we generate data. And we talk about the volume, talking about the amount, okay? Then the complexity talks about how, what should I even put it? Like the structure, okay? How, yeah, the structure, how the data is, okay? Some of the data, simple. For example, if you come to the hospital and all they are collecting is your date of birth, that is simple. They can put in an Excel sheet. But if you take a scan, that is a complex image, so a complex data. All right. So the data, the amount, and also the complexity, they characterize what our data will be. All right. Now, once you have your data, you can process using what data processing tools. Others use Excel. Excel is there. We also have other systems or platforms that you can use. But the difficult thing with you processing this data is sometimes you have a lot of challenges. Okay, you have a lot of challenges because one, you need to clean the data. Why the data is full of what errors? They are unstructured. We have to filter, organize, validate. All these things, okay, are issues or challenges that data scientists face when they are working with data. So what do we do? AI will come in. So that is why we need AI in healthcare and medicine. So when we try to use AI technology, okay, to process, diagnose, or treat patients, I mean, that is, we call it AIM, okay, artificial intelligence in medicine. So here, whatever method that we have or we use in a hospital, we try to what? Integrate AI or use AI as part of it. Okay, use AI as part of it. So what AI or AIMS use is to perform clinical diagnosis, suggest what treatment. That doesn't mean that the doctors are not important or the healthcare personnel are not important. Okay. Now, if you use calculator for any exams, sometimes when you punch the thing, you still want to verify.
Password Sunday one.
Giggle, garbage in, garbage out. Okay. So whatever you put in is whatever you are getting. So sometimes, although they are using us or they are helping us to be able to diagnose certain diseases and also suggest treatment, we still have to critique these AI systems. So what it does is that it facilitates and also enhance human work and not replace the work of physicians and other healthcare staff as such. So have it at the back of your mind that it's like a tool. Okay, so the more tools that you have at your fingertips, the better you can work. But if you have no idea of artificial intelligence, you will be like, oh, the caveman, right? So remember, it's a tool and it's not going to replace anybody's work. But those who have these tools, they will be able to work faster and much more efficient. Okay. So I ask you what an intelligence, I ask you guys. So I ask you guys what is intelligence, and some of you define it. So can you name any intelligent person? You say Elon Musk is the intelligent guy. I saw some of you Einstein. I think only 2 or 3 of you mentioned your name, and one guy also mentioned my name. So you are not intelligent. So let's assume those that mention other people, okay, except the guy who mentioned my name, they are all not intelligent. But let's find out if indeed you guys are not intelligent. All right. So when you define the term intelligent, what is it? So human intelligence is our mental ability, one, to take decision, two, to solve problems, and three, to learn new things. No, so don't tell me that this morning you didn't take any decision. You took decisions, right? So that means you're an intelligent human being. You solve problems. It's not only academic problems, but some of you are having all sort of problems, okay? Family problems, health problems, and you are trying to solve it. So when you solve it, that means you have intelligence. And you also learn something new today. Don't tell me you didn't learn anything. Even if you didn't learn anything, you learned some funny thing today or funny statement somebody made. That means it tells you that you are intelligent. So when you define intelligence, you're just trying to say that you have the mental ability, one, to take decisions, two, to solve problems, and three, to learn new things. So you said Elon Musk. So I don't know what is so intelligent by Elon Musk because he's building those things. All right. So can a machine also do these things? The answer is yes. So when I asked you guys to define what artificial intelligence, I saw some of you saying that you making machines having the ability, one, to take decisions and also to learn, or trying to give certain human-like features to machines. What are some of the human-like features? Ability to take decisions, ability to learn new things, okay, ability to also, yes, when you see something, you're able to take decision. Also have the ability to solve problems. Now, some of these things we can give it to machines. But one thing we have to know about intelligence is intelligence is not one way. We have different types of intelligence. So I always talk to people that we are all intelligent in one way or the other. We have people who are good in terms of sports. So the Messi and the Cristiano Ronaldo, you find them here. Then visual spatial, we have some people, they are good observant. Okay, they're able to observe patterns and explain things to you well. Then we have the Einstein, those who mentioned the Einstein, they are good with the mathematics and the logic. All right, then also have what interpersonal, then also have what intrapersonal. You have some people, I mean, when you talk to them, sometimes after talking to you, my problems are solved. You see, that is the person's intelligence. those who do counseling, guidance, and counseling, they have that intelligence to be able to what? One, take decision based on the problem you are sharing. Okay, then they'll also be able to solve problems because you are giving them your life problems and they are trying to help you solve. Okay, and they also learn from whatever thing you are sharing with them. They also have what? Intrapersonal, then naturalistic, the music, Carry them, the Shatawale and the Stoneboy will be here. We also about linguistic verbal. Today I had a meeting with my professor and was saying that he uses different ways to grade his students. One, some of them you come and do presentation. I wish I was in Tamale. I mean, I think that one would have been the best. You write exams, you also do presentation. I'll call you one by one and I'll ask you, Anthony, do this, explain this. If you're able to do it, and I check your exam score, and I mean, I can say, okay, because you're able to explain all these things, I'm giving you 100 or 90. Okay, so I mean, we are all different, okay, in different areas. Some people verbally, they are good, others, they are quiet, but logically, they are also good. So know where you are and build on that. So it's not always Elon Musk and Einstein who are intelligent. You're also intelligent, but you're not paying attention to it. All right. All right. So now let's bring the definition of intelligence to define what artificial intelligence actually is. So it's a machine's ability to take decisions, solve problems, and what? And learn like all humans. But if you want to define it in a good way, then we say that it's the development of what? Intelligent machines capable of performing tasks that typically require what? Human intelligence. So we have machines that can perform certain tasks that require what? Human intelligence. What are some of these tasks? Ability to take decisions, to solve problems, and also what? To learn new things. That is AI. The development of intelligent machines, okay, or development of machines that can perform certain tasks required by humans. All right. Okay. Now, we need to be able to distinguish between automation and artificial intelligence. They are not the same. When you automate a task, you are repeating the thing over and over and over and over and over again. There's no learning over here. What distinguishes AI from automation is the learning. AI requires.
If you go on there, you can access it. But after 7 days, the baby will just selected.
Okay. People are preaching also very cordial. Okay. So automation is different from artificial intelligence. Okay. What distinguishes between these two is when we talk about AI, or yes, AI, we saw it. What we want to take decisions. Automation also can also take decisions. They can also solve problems. But the only thing is
My wife. Now you get network idea.
okay. So it's the learning. It's the learning that distinguishes automation from artificial intelligence. Okay. So when you take these automatic doors, when you get close to it, it uses what? Your motion sensor or pressure sensor to open it. Okay, that means one, it is taking a decision. Two, is solving a problem of what? Of opening the door for you. But if a dog stand in front of it, or even you just try to put a box in front of it, it will open, right? Now, it will find it difficult to distinguish what humans from what non-humans. That means it is not learning. So AI will be able to learn and know this is not a human, so I should not open it. This is human, I'm supposed to open. All right. So let's find out. So automation is a way to make machines work on their own. AI also the same thing. Automation needs little or no human help. But what makes automation so interesting is that it makes physical work easy. Physical work easy. So when you have a washing machine, you are automating your tasks, automatic doors, escalators, We have example, a couple of them. You can search. All right. So what automation does is it makes physical work easy. But what about AI? AI makes mental work, okay, easy for humans. It's going to make mental work easy for humans. So when you want to distinguish between these two, automation is to make machines work on their own, but in AI, you're making the machines think. Here, the machine is learning. That is what distinguishes it from automation. Okay, so the machine is going to learn, but in automation,
Charlie, my network.
it's just automation. It is just doing the same thing over and over and over again. Right? There's no learning. Okay. Now, how will you recognize artificial intelligence, whether a system is what intelligent or not? Okay. In order to do that, we use a test known as the Turing test. This is Alan Turing. I don't know if you watched his movie before. The guy who helped to break the Enigma code. Okay. There's a Turing test, and this Turing test is what you use to be able to distinguish. Please inform your colleagues to mute themselves, okay? They are giving a lot of feedback. All right, so we have the Turing test, and it's this scientist, Alan Turing, who came out with this test. He contributed much to artificial intelligence. We normally say that, I mean, his work is what other scientists build on for us to have what intelligence. Dorothy, please mute yourself. Right, so we came up with a Turing test, and we use the Turing test to evaluate whether a computer system is intelligent or not. Now, how is this done? Let's find out how you can perform a Turing test. All right. So if a machine can carry out a conversation which is indistinguishable from a conversation with a human being, then it will be reasonable to say the machine is thinking. So this is how they do the test. So the test, I'll come back. So they'll have an interrogator here. So let's assume this is Anthony. All right. So then Anthony, there's a wall that is separating Anthony from a real person and also an intelligent machine. Now, Anthony is going to interrogate, going to ask questions. So if Anthony keeps on asking the question and Anthony is not able to distinguish that indeed the machine is, one of them is a machine, and he's just assuming that they are both humans, that we say that, oh, this machine is what is intelligent. So when the interrogator is not able to distinguish the machine from the human through the conversation, then we say that what the machine is what is intelligent. Okay. And you all testify that sometimes when you use some of these AI systems, when you try to question it, you know this one there is a machine because it keeps on. There's a term that they use, it hallucinates. Okay, you try to hallucinate things that you didn't even ask. All right. So when you perform a Turing test, okay, the interrogator will find it difficult to distinguish which one is the machine. All right. And when it happens, that is what a Turing test. So the Turing test stands out as the first contribution to the philosophy of artificial intelligence. We all use Turing test. So when we were creating accounts on Kaggle, we use Turing test. So if you've seen this thing before, when you're trying to create an account, we are trying to do something online, you see the captcha and the recaptcha. That is a Turing test you are doing. Okay. They do this in order to protect their system, right? Because we have hackers all around. So some of these hackers, they can send a lot of traffic to your server. Okay. If they do that, they will crash your server. So in order to prevent these bots from sending a lot of traffic or a lot of requests to your server, you need to prove to us that indeed you're a human. All right. So what you are doing is that you are doing a Turing test, because these bots, they are not able to do this. They are not able to do this. So we are still using Turing test for security purposes. All right. So what are the roots, or what is the root of AI? So first, hey, today I'm in trouble. Okay. All right. Please, Anthony and Co, please inform your people that they should mute themselves, okay? Or else I'll end the session. I'll end the session. Okay, so I want to know how AI actually started. We saw the work of Alan Turing, that he came up with a Turing test. So it is Alan Turing's test that laid the foundation for others to work on. But we have other scientists, I'll mention their name. Their work also laid the foundation for other scientists also to build up. Okay, so John McCarthy, okay, this guy, okay, he organized. Okay, so John McCarthy organized some group of people, and it was actually a funding from this guy, or this American, this guy, I forgot his name. Was a very, very rich guy. Okay, he funded their research, and in 1956 at Dartmouth College, and they wanted to find out, okay, how to make what machines intelligent. Okay, he is the one who coined the phrase artificial intelligence. Okay, and he wanted to distinguish this from another, term that they were actually working with. Okay, that is cybernetics. All right, so he just coined artificial intelligence to make it different. Right. So he organized this group of scientists. These are the pioneers or the founding fathers of AI. We have John McCarthy, that's the name over there. Claude Shannon, this guy is the one who worked on information theory. It's also part of AI. If you want to dig deeper, you understand it. Then Arthur Samuel is also work on machine learning. Machine learning tomorrow, when we talk about Arthur Samuel. Then also have Marvin Minsky. All right, so this guy also. Okay, so the rest, they all contributed, but these three other guys, you normally see their name a lot in papers. So these are the founding fathers. So it was the Dartmouth College, that conference that led to what? To artificial intelligence, the research in artificial intelligence. Okay. Now, we have milestone, a lot of milestone along the way, and some of them has actually revolutionized the world, has also done a lot of things. All right. Now, 2023, we saw GPT-4, okay, coming out, and we are all using it, right? But before GPT-4, where did we start from? So 1950, Alan Turing test, which is the Turing test. Then 1956, Dartmouth College. Then the ELIZA. Now, chatbots started way back before even we are having Siri and Alexa. Okay, chatbots started way back. So Eliza, as you see over there, was actually a chatbot that was done or built for hospital, okay, and healthcare to solve healthcare problems. All right. Then we call something the AI winter. The AI winter is where fundings of AI decrease. Okay, so they were not pushing money into AI research again. Why? When they first started with artificial intelligence, okay, we have people who contributed. We will learn about it later, either Thursday or Friday. Perceptron. When they build a perceptron, it can only solve linear problems. But remember, we are living in a world which is what? Non-linear, chaotic universe. So don't expect things to move in a linear way. So when the perceptron was built or when they developed it could only solve linear stuff. Non-linear problems became difficult and there's nothing they could do. So people started what? Withdrawing their what? Funding till the back propagation algorithm, which is the gradient descent, okay, was introduced. So when that was introduced, then the AI took over. And since then, we have seen increase, okay, in terms of IBM Deep Blue defeating Gary Kasparov. We also saw Google self-driving car project, then IBM Watson winning Jeopardy, and all the way towards ChatGPT now that we are all using what GPT. All right. So these are some of the milestones. The same thing also we see in healthcare. Um, some of them similar, others different. So when you take the slice, you can go through, okay, and find out a lot about some of the milestones that we have. So we see the AI winter, you see it over here. Okay. Then also have the second AI winter. So sometimes the what you expect the research to do is if they're able to do, then we try to retrieve the funding. Okay. Uh, so these are some of the devices. All right. Okay. So let's move on. All right. So these are some of the new systems that we have: Artris, Farmerboard, Alexa, Siri. These are all AI systems that we have now. So how AI works? First, it accepts data. All right. Then it has to process the data using various rules and algorithms. Now, I said earlier when I did explain that some part of artificial intelligence, okay, or majority of AI systems, they use data. Without data, they cannot work. Data is very, very important. That is why there's a saying that data is what? Is gold now. Data is gold now, okay? When people have access to your data, they can manipulate to do all sort of things. Okay. So first we need data. And the second thing is to process the data. How is the data processed? One, we need rules and algorithms. So we need rules and algorithms. Okay, so these rules and algorithms is what we quote anytime we are working with any AI systems. Okay, we need to do that. So once we process it and we use the rules and algorithm to process it, the next thing is to give the outcome, whether it's a success or a failure. All right. So the outcome that comes out, we need to analyze it. So once we do the analysis, the next thing is we want to say to ourselves, is it fine? Can we go on? Or we should improve and make the rules and algorithm better. So it's going to be a loop. So this loop is going to continue over and over again till the outcome that we are looking for is close to the real one. Okay, it's like you teaching. Hey, today dear, I'll be in trouble. Somebody is cooking. All right. All right. So we loop over and over again till we get a desired result. So first, you accept the data. Second, you process the data using what rules and regulation. Rules and algorithms. Then you predict your outcome. Once you predict your outcome, you need to analyze it and check, compare it to the actual result. If it is okay, we can leave it there. If not, we need to go back and assess our algorithm. So that assessment has to go on and on and on till we're able to get the results that we are looking for. Okay. So that is how AI systems work. All AI systems take in data, process the data using rules and regulations. Then they will predict the outcomes. Once they predict the outcomes, we need to analyze it. Once we analyze it, we go back and assess the algorithm, the data, and the rules to make sure whatever we're looking for is it close to the real value. If it's not, let's go back. So we keep going back. So it becomes like what? A loop till we get a result that we are looking for. So this is a diagram that shows. So we have our input data. These are our data. Then you have the rules here. You have the outcome here. So when you predict, okay, this is where the learning takes place. This is where the learning takes place. So here, if you look at it, we come here, then we come here, then we go here, right? But look at the adjustment over here. So anytime you're going to do any adjustment, we need to adjust our data, we adjust our algorithm, we adjust what our rules. We call it you are updating. Okay, so you need to update to make sure that your outcome is close to the solution or whatever thing that you are interested in. When I come and we are doing practical, you see it when I say you are going to train our model. And after once you train your model, you need to calculate something else, your cost or loss function. So if your loss function you calculate and you get an accuracy of let's say 90.3, it means your system is close to the real value. Okay, all right. If not, if you do your accuracy and you get something like 50, that means your model is not learning. You have to go back. So we have some fields of AI. We have different. Okay. Now we will talk about deep learning. We also talk about machine learning. We also talk a little bit about natural language processing, but we are not going to go deep or we are not going to code. Okay. We will look at it application and the application in terms of generating medical report. Okay. Computer vision too. It's also there. This driverless car, they use that. Then neural network, we also talk about neural network, it's also part of our deep learning. Then we also have the cognitive computing. So these ones, you're going to talk about these four, okay? The rest, you can go and do research, read more about it. All right. Okay. So what is the value proposition of AI in health? First, one, lower cost of care. All right. Now, somebody is thinking, so why do you think AI is going to lower the cost of care? Now, they use it in drug discovery. They are using it in all sorts of things. That's the research I'm working on, that if you want to discover a drug, it can take you 10 years, right? The material, the resources that you use. But if AI comes in and facilitate the process, one, it reduces your cost, so lower cost of care, right? Now, for example, if you take a scan and the AI can tell you or can pinpoint or can even accelerate the diagnosis instead of the doctor say, go and take another scan, you can take about 100 scans, then the doctor is still confused. Not that the doctor is no good, but the doctor, we are humans, we have what human error. Okay, so sometimes we find it difficult to be able to see some of petty or detailed things, but computers can do that. So instead of you taking 10 scans, the AI will let you take one scan, but that one scan be able to extract that feature that we are looking for. So saving what? Money. All right. Then improve patient's outcome. You saw in the first slide, 2 or 3 slides, I made mention of what? Personalized genomics, okay, where your data alone, we can use your data alone to be able to what? Know your health history and be able to predict certain drugs for you. So that it's not like one for all case. It's going to one for one or one to one. Okay. All right. Then patient's experience. Once you're improving patient's outcome, then experience also what? I mean, it will be fun. Now, in such a way that we have Apple Watches that can collect your vitals in real time. So to know whether your pressure is high, know your pressure is low. All these things made possible by what? By AI. All right. Then improve providers' experience. Okay. Now, you all agree sometimes when you use these platforms, it helps you a lot. Okay, sometimes something that maybe you did not even take a look at it. When you use these systems, you're able to say, oh, okay, so next time I have to look at here, or I have to look at this place, or I have to pay attention to that. So these are the value propositions of AI in health. Now, why is AI of increase? I made mention of the first one was data. Okay, so that's number two. Enormous amount of data presently at hand. That means we are generating data on social media. Social media, the amount of data we are generating, we are generating data each and every day, each and every time. Okay. Then second, more computational power. Now GPU, graphical processing unit, okay, has made training of what deep neural network possible. Okay, GPUs training your model on CPU, it will take a very long time. But GPU, oh, if you know the company Nvidia is making what big money now. All right, because of the GPU it produces. So we have better computational power to train deep learning models. We also have a large amount of data at hand. Okay. Now I know the number of scans that you guys take in the hospital. I can count. That's quite a lot. Then better algorithms. You have better algorithms. When we talk about algorithms, we are talking about the steps or a recipe that you follow. So our ladies, when you guys are preparing food, you are preparing soup, whatever thing you do in this life, that is an algorithm. Okay, it's a step you are going to follow. Excuse me, if you want to go and speak to even to a lady cry, sometimes you have some steps you follow, right? That is an algorithm. So algorithms are all around. In computer science, in computing, what most of the time we are interested in is the efficient one. Okay, the efficient one. So that's why we use the word better algorithms. So if your algorithm is doing the thing in 1 minute, and I build an algorithm that can build in 30 seconds, mine is better than yours. You go for my own instead of yours. So better algorithms. They also have funding from other companies. The big tech companies. Facebook is here, Amazon is here, Alphabet, Netflix is here, Google is here, and this Acra, what is this company? I'm forgetting the name of. All right, there are 5 companies. That's Alibaba. Is it Alibaba? I don't know whether it's Alibaba. I think Alibaba too is contributing. So the big tech companies or the monopoly companies that we have in this world, they are providing funding. Legon, when you come, one of our Professor Riafe, Legon is sponsoring him, pumping huge amount of money into his projects, okay, because we will benefit, who knows. So they are also funding a lot of research in AI. So that is why AI is of increase now. All right. What are the types of AI that we have? We have narrow AI, general AI, super AI. Now we are all here. We are all using narrow AI. We are not even getting to AGI. Okay. If you get to AGI, that is going to be dangerous. Okay. Super AI, I don't think. Somebody said when you get to super AI, I don't think we even give birth because we'll be creating our own babies, we'll be creating our own animals, and we live, everything is going to be artificial because super AI will be very, very dangerous. Okay. So let's find out, what these three they are. So narrow AI here, AI systems designed to what? For specific tasks or problem with high accuracy. They are also known as what weak AI, or it's also known as what weak AI. So when we talk about narrow AI, weak AI, I mean the same thing. But remember, they are designed to, or it is designed to perform specific tasks. You will tell me that all the AI systems that we are using now, they are all designed to perform a specific task, right? All right. One thing is that it does not possess consciousness or genuine intelligence. That's why I use the word it hallucinates. When you say something hallucinate, you understand? It's trying to tell you something that is not there. It's like the guy is dreaming. That is what AI system does. So that is why if you use these systems to submit your quizzes and project work and you don't read it or you don't go, you think you are so busy that you don't even read it. Some of the lecturers or some of us, we have time, we'll go through. And if you catch you that use AI, you didn't even take your time to be able to go through to correct errors, we score you zero. Because sometimes these generative AI, they hallucinate. They tell you things that isn't true. They are not even there. They try to manipulate their own way out. Okay. And there's a term I always tell my students, there's nothing intelligent about these systems. They are all mathematics behind. Mathematics trying to manipulate data in order to deceive us that this thing is what intelligent. There's nothing intelligent about it. It's just mathematics.
Franklin.
It is mathematics. All right. So these are examples of narrow AI. Okay. Then we move on to AGI, general AI. Okay. So these systems, they are designed to have human-like intelligence. Human-like intelligence. For example, they can understand, they can learn, they can reason. It's also known as what? Strong AI. Somebody is saying, say, what about generative ChatGPT? Can ChatGPT reason? ChatGPT is not reasoning at all. Okay, is ChatGPT learning? Yeah, ChatGPT learns because it's an AI system. Because when you keep querying it over and over and over again, okay, it will learn from it. Okay, is ChatGPT does it have understanding? Yes, when you give it a query, it has to understand before it be able to give you the answer. But is it reasoning? It's just using mathematical algorithms at the background to be able to present solutions to us. Okay. Now, this type of AI still remain theoretical because one, for us to get to human intelligence is not something small. Okay, the human system or the human brain is quite complicated. So even we learn it either when Thursday or Friday when it's talking about deep learning, where we see that they try to replicate. You can't replicate the brain, but you can replicate some processes of the human brain, able to use it not in computing agents. Okay. So for the AGI, it will entail machines have self-awareness and ability to use judgment and intuition to make decision. Self-awareness. Is ChatGPT self-aware? Okay. Does it have intuition? All these things, they don't have it now. So we are still at ordinary AI. Then super AI, this is dangerous. Okay, this is very, very dangerous. So this AI system will surpass human intelligence in all aspects, from creativity to emotional intelligence to general wisdom. Can you imagine that maybe you're not feeling well and ChatGPT will say, "Hello, Anthony. I can see this morning you're not in your mood. What can I do for you?" Okay, that's emotional intelligence. Just looking at your emotions, be able to say something small. I don't know whether you watched this movie, the Big Six Heroes or whatever, Base Mark, that toy thing the guy built to be able to help. That is super AI. Okay, the device can look at you or the machine can look at you and say, that, "Oh, today I don't think Anthony is good. I need to say something to be able to help him." All right, so it will possess the capabilities far beyond human abilities and have an unpredictable intention beyond human control. This is what people are normally scared that, hey, this system that we are building, won't they get out of hand? I can't tell. Okay, you guys are coming. So I don't know in the near future what is going to happen. So we are here, narrow AI, which is NI, okay, or ANI, how you pronounce it. Then you also have the AGI, okay. Then you are going toward the AC or the ASI. All right, so we are here. So we want to get to this place. So people are doing a lot of research. Now, if you check America and China, it's now a serious competition between these two countries because a time will come. Those who is going to monopolize the world will be masters of AI. So let's clap for Professor Nash by introducing this course. It was very, very important. A time will come, I tell you, the AI guys or the AI companies, they will make, millions, millions and millions and millions and millions. And it's going. So make sure, irrespective, don't say that, say, I don't know how to code. No, I told the level 300, no one is going to code. Now, generative AI can even code. AI can code for you. So the best thing is understand the concept, try to build small, small things for yourself. All right, who knows? You might need it one day in the near future, and I'll not be done. All right, so when we when we hey,
AC.
okay, so when we spoke about the milestones of AI, we saw the Alan Turing test, then we came to the Dartmouth College conference, then Eliza. Wow, I think you guys, there are a lot of things you guys don't know. Eh? Please, you're in a classroom, so you can't be making fun and all. All right, I've heard you. Okay, you're in a classroom, so at least you should have a book and a pen beside you. Okay, I'm not scaring anybody, but you guys don't know what is coming. So don't take this thing for granted. Oh. All right. All right, so we have the fundamentals of AI breakthrough. So we have Gary Kasparov versus IBM Deep Blue in 1997. Okay, IBM built a software called Deep Blue, and it competed with Gary Kasparov. He was the world chess champion, and I don't know how many rounds they won. I think is it 4 or 5. The first one, Gary Kasparov won. Then the second one, Deep Blue won. The third one was a tie. No, the third one, Deep Blue won. Then the fourth one was a tie. Okay, that was the first time a machine has been able to beat a human champion. Okay, in chess. Then we also have the Jeopardy champion versus IBM Western, another software built by IBM, and IBM Western won. Then what actually shook the world was the Alpha Go versus the Go world. Now, the Go game is similar to the chess, but that one is quite complex. If you Google, you find out it's much more complex. Okay, and you're able to build an AI system to be able to beat the world champion Alpha Go. So these are some of the breakthroughs that we have seen in AI, and we keep seeing them. Okay, this is also image recognition, where the build AI system able to recognize a lot of image sets. Okay, those of you who are into AI, you will know this. Okay, all right. Now, application of AI in healthcare, our main focus is going to be here because we are in what? The medical imaging and radiology. You use it in virtual nursing assistant, personalized medicine, I made mention of personalized medicine, drug discovery and development, I made mention of it, robots/AI assisted surgery, recognition of facial symptoms and administrative efficiency. So now here, if you go to the hospital, and this is not the time you're now going to pull your folder and all this. No, they'll just mention your name, Anthony. And when they type Anthony over there, they will now go, the system will now pull everything in regard to Anthony, and it will tell the last time Anthony came, what treatment was given to him. So So this is our focus in medical imaging and radiology. All right. So these are examples of AI systems or the application of AI. Da Vinci, you know Da Vinci. All right. So these are robots that are used in our surgery. Then also have the Botkin AI, that is your field. Okay, used to analyze scan from MRI. Then also have your MD, a chatbot that can help you to be able to know your health. If you are sick, you can query it, able to prescribe prescription, all sort of things for you. Then the cardio, this one tracks your record, your daily vitals, and report them to you. All right. We also have this phase to gene. This is for Down syndrome. Okay, patient is able to help detect. Then we also have the Healthify Me. Your glucose level can keep track of it. Then the gym fit. Okay, when you go to the gym to do some workout, you can also track all this. So people are building. These are just examples that people are building. I told you that we're trying the same thing. I mean, most of you, your focus is just to get your degree, get your certificate, and go. But let me tell you, there are a lot of problems out there that no one is going to solve it if you guys don't solve it. So start thinking, what can I use AI to do in my department, my radiology department? There's no way the certificate. Okay? All right. So if you are chasing the certificate, then you are not going to solve any problem in this world. But those who look beyond the certificate, they are the people who are changing the world. That is why you made mention of Elon Musk. There's nothing special about him. Just look beyond his certificate. All right. So here we also have other examples. So all this is application people are building. You guys, you take scan each and every day when you go. Okay, so you take scan.
Oh, try your point.
All right, so you take scan. Now look around. What can you do? All these things are things that you have to start paying attention to so that you're able to do that. So AI versus machine learning versus deep learning. We'll talk about this, but let's look at it from here. So AI is the bigger umbrella. The machine learning is inside. Then deep learning is what is embedded in machine learning. So we said AI is you what giving machines what human some form of what human intelligence, right? So here we try to give machines some form of human intelligence. But when you talk about machine learning, we'll talk about it tomorrow. Here, you are telling the machine to learn from data, but you are not telling the machine how to do it. Okay, so you give the machine the data. He said, do learn something from the data, but I won't tell you what to learn from the data. Then the deep learning try to use knowledge from how the human brain works to extract complex patterns and features from data. So each one and what we use it for. We'll distinguish between ML and deep learning. Why do you have to go for machine learning? When do you have to go for deep learning? All right. So AI in medical imaging and diagnostic. Now you take scan each and every day, but as I said, in healthcare, they learn along, okay, because humans, we are complex. So sometimes you take a scan, you take another person, is different. So we learn, okay. And our work is also time constrained. So in a lifetime of a radiologist or a radiographer, how many scans can you take? How many scans will you be able to read? We are limited in terms of knowledge and experience, okay? So the experience you have is equivalent to what your working experience. So if you work in the hospital for 10 years, that's the experience you have. But in computers, they are different, okay? They can learn huge amount of data within the shortest possible time. Okay, so computer software through application of algorithm can gain far more experience significantly in shorter amount than human beings. All right, so that is why we are trying to integrate AI into the imaging department. Because if you take this over 40 productive career years, a radiologist will look at approximately 225,000 odd MRI CT scan. But this data is too small for a computer. You can give it millions and millions and millions to be able to what? I mean, gain experience far more than the human. All right. All right. So this is something they are trying to use AI to be able to what? Discover features and also extract patterns and features from. All right. All right. So artificial intelligence, we are talking about radiology now. That means we are now in your field. Okay. So when you talk about it in terms of your field, we are trying to redefine the traditional workflow and elevating radiologists' role. We also want to augment and optimize, okay, and also we also want to structure and annotate. Now, all these things are very, very, very important in your area, okay. If we can use AI to redefine the workflow of how radiologists or radiographers work, I mean, it's going to help a lot. Then augment scanning procedures, optimize images. All these things, as I said, these are, I mean, things you guys have to consider when you guys go for clinicals, because you can do a lot of things over there, but some of your mind has not gone there, or you not even pay attention to what we can use AI to do. Structuring and annotating of data, we can use AI to do all these things. I remember the first time I came to Tamale, they told us that TTH, anytime you're going to take a scan, you need to carry a pen drive along. So that means if 100 people are coming, the pen drive company will make money. So I said, then if I'm into business, I just go and put pen drives, okay, in front of the clinic or the hospital, and I'm able to get money. So all these things are things that we can use AI to help solve. All right, because if they are coming purposely to take a scan and they are carrying pen drive along, that means trying to tell you that the data or the scan that they took so big that they can't send it through the university network. So what can we do? Can we use AI to be able to to compress the data so that we don't lose much information? These are things that you have to start thinking about as a student. All right. So we can also use it to validate and optimize. Okay. Now you guys will bear with me. Nowadays, excuse my language, but nowadays some of the nurses that are coming, to be frank, some of them are careless. I have to be honest. Okay. It's in such a way that treatment plan and reports, they contradict each other. Okay. The doctor will say, give the patient this amount. The nurse is so busy on her phone that he or she will forget what the doctor said. Or sometimes too, is the doctor will make the mistake, then the nurse has to correct him or her. So we can use AI to validate some of these things. Okay, the report you are coming out with and your treatment plan, I mean, there's form of what discrepancy. That means, it doesn't correlate, right? In such a way that there are two things. Okay, AI can draw attention to that. Okay. So what are some of the practical applications? First, image segmentation and classification. We can segment. Okay, so when we talk about segmentation, we talk about it trying to put an image that you take the part into different regions. So here we are segmenting. So here it's trying to tell you that this is a tumor, this is not. Then once you segment, you can go ahead to classify, also have classification. So you can classify your different disorders into their respective kind, right? Then we also have advancing diagnostic with AI and CAD systems. So some of these modalities that are coming, okay, devices that are coming, you see AI has been integrated. I don't know if Seth is here. He last time shared a testimony with me that there's a system that they work with and they have AI integrated in it. All right. Then we also have prognostics with radiomics and predictive analysis. Now, the amount of data that are being generated is quite a lot, okay? So how can we obtain, okay, patterns, extract features from all these data? AI can assist you. That is what radiomics. We'll talk about it. Then workflow optimization, as I said, okay, sentimental analysis or sentiment analysis, machine translation. That is research people are doing now in computer science, University of Ghana. One of our professor, Professor Riafe, I mentioned the name is Techrema, is working on an app that can translate between P and Ewe. And so P and Ewe to English, and English and sorry, P and Ewe to English, and English to P and Ewe. That means when you are talking, doesn't matter whether you try to bring in English or not, the system will be able to understand this, okay, and generate all sort of, things for you. If I say generate all sort of things for you, it can communicate with you. Doesn't matter whether switch from English to P or P to English, the system will still be able to understand. Now, sometimes people are saying something, but what? They are actually thinking about something different. They are not the same. So AI can be able to do that. So language generation, answering questions, text classification, sentiment analysis, and machine translation, all these things. And they're even building an app to be used at a hospital. Maybe I'll tell you the app tomorrow, or forgetting the name of the app, okay, that they are using at the hospital to help streamline a lot of things. These things, it's not only you guys, not you only go to the clinic, go and take scan. No, start thinking around. What can you do to be able to streamline some of these things? And we are waiting on some of you. All right. So these are also applications where you see, so neuroradiology, AI is also helping a lot. Then you see oncological imaging, AI too is helping health detection and all sort of things. Then you also see cardiovascular imaging to AI. So we have an application over there. AI is helping them a lot. Then abdominal imaging, AI is also playing a major role over there. Right. So let's talk about the last part. Then I'm done. Limitations and ethical challenges of AI. All right. All right. Now, when you talk about ethics, I should have been asked you, but I've already shown the slides. Now, this goes to all of us, okay? What is good and what is bad, right? That is it. What is good, what is bad, or what is moral, right? That is AI, that is ethics. So you think this thing that you are doing, you yourself, you know morally it is what? Is wrong, right? Or you know that morally it is what? Is good, right? The same thing in AI. We build AI system to complement, to help, not to do bad things. That is why when you use ChatGPT, you try to create ChatGPT bad information, it will not work. Okay, it will not work. When you try to do that, it will not work. Okay, they will tell you that no, I can't do that. Okay, I've been programmed not to do this, it will not work. Okay. Okay, so sorry. So AI ethics is a set of guidelines that advise on the design and outcome of artificial intelligence. Now we have certain principles that we need to stick to. Okay, and all these principles should be in your head. Okay, the first one, we design AI system to be fair. AI system should treat all people fairly. And I don't think the AI system we are having here, they are fair. They are not fair. Then reliability and safety. AI system should perform or should be able to be reliable. We need to rely on them. That this thing that we are using, one, is not going to cause any harm. All right, then privacy and security. It's supposed to protect our data. Okay, it's supposed to protect our data because anytime we keep querying some of these things, we share our secret. I heard a professor saying that apart from God, okay, the person who knows us best or better than even our parents is Google. Google knows all of us, the things we be doing online, all our secrets, everything. Okay, so privacy and security. Then inclusiveness is the same thing like fairness, okay? You should include everyone. When they first built the Google search engine, when you try to type certain things, it was biased. When you say an AI system is biased, you try to what? skew its answers towards a certain group of people, okay, leaving others. But AI systems will always be biased because there's no way you're going to collect data from the whole world. Now, even when Google comes to Africa or Ghana here, I don't think they can go to the village to be able to collect more data from there. So AI systems will still go up with bias. Then transparency. This is a question I will throw, an assignment I'll give it to you guys for you guys to go and research. For example, Anthony took a scan, okay, and he's now want to talk to the patient, and he told the patient that, oh, this is what is worrying you, but I use AI to do it. But the answer the AI gave it to me, I don't even understand. I don't understand. But the AI said, you are suffering from this, and I know it is true, but I don't understand. Transparency. You need to be able to understand AI systems, and that is a new field altogether known as explainable AI. Explainable AI. People are now doing PhD over there, where their main focus is to be able to understand why the AI made the decision that it made. Okay, then accountability. People who build AI systems, they have to take responsible, so they have to be responsible for whatever action the AI system do. So if, for example, you use generative AI and it does bad, you use ChatGPT and it does something bad, those people who build a system, they have to be accountable. Okay, so these are the 6 principles of AI systems. Okay, and all of them has to be in your head. I'm saying it. All right. What are some of the challenges in adopting AI in the clinical practice? First, ethical considerations. As I said, it requires a lot of data. Now, one of the issues, so most of you are Gen Zs. One of the issues some of you take for granted is you throw your data anywhere. Okay, you share things online. Some, especially our ladies, when you are eating, they post. When you are drinking, they post. When you are working, they post. But in the hospital, anytime you pick a patient's data, that is, you can't pick somebody's data. They can sue you. It's here that we take some of these things for granted. You can't use my data without my consent. You can't use my data without my consent. So people who build AI systems and they use people's data without their consent, that is a crime. Okay, it's a serious offense. Okay.
So this I'm on this on lecture, so and
So the issue we face at the hospital is that you can't joke with the hospital data. Our health, you can't joke with it. You can't go and pick somebody's health data and you are going to train your model with it. No, you need to go for ethical clearance, right? You go for ethical clearance to make sure that you've been given the go ahead. So that is another challenge we are having in adopting what AI in clinical practice. Second one, validation and standardization. Now, I made mention that AI systems are what? Actually biased, right? Yes. You never have a perfect AI system because the data set that you use to train the AI system, okay, it will suit to that data set. So, for example, if I come to Tamale and I build an AI system and I use the data set over there, when I bring the AI system to Kolebu in Accra here, it's going to be biased. Okay, so that is another issue. So ensuring that AI algorithms perform reliably across diverse patient population is actually a challenge because they're all different, okay? And people are doing well. Yeah, we are increasing the amount of data, okay, but still AI system are, okay, it's still biased. All right, then integration with existing systems. Okay, now if they now want to come to TTH and try to integrate AI systems, that's going to be a challenge now, right? Integrating system to another system sometimes becomes difficult sometimes, okay? The reason, not because maybe they can't, but we have data already there. Are we going to do a complete changeover, clear everything and put the new AI system over there, or try to do phase or do piloting or do the different mode of implementing a system? So when you're trying to implement or integrate a system, sometimes it becomes a challenge. Then physicians training acceptance. Now, if they now integrate a system into the hospitals or the individual hospitals or the hospital we have, you need to first train the people who are going to use the system. That's another money, right? So physician training acceptance. And some physicians, they don't like it at all. Not that it's going to take their job, but one, as I said, AI sometimes hallucinates. Okay, what is not there to try to fabricate things and lie. So we say AI can lie. It's like you are sleeping and you think that you are United States, but you are in Ghana, right? So AI is just hallucinating. Sometimes if you don't take care, I mean, you end up diagnosing something that is not there, and the person will be in trouble. Then bias and transparency, I made mention of it. Okay, so AI systems, no, they are all biased. Take it from me. All AI systems are all biased because of the data set we use, right? Mhm. So, in my opinion, I mean, each country should have its own AI system. So, Ghana here, we should have our own ChatGPT. We should have our own AI system for our education, all sort of things. Because the way some of these things are trained, they are trained using the people who built it, that country data set. All right. Cost of implementation. Yes, adopting AI in the long term is quite affordable or cheap, but when you're adopting it, hey, Tracy is cooking on. When you're adopting it, at first, it's quite expensive. Okay, why? Because you need better computing systems, cloud. Now, when you try to, I believe most of you, your Google Drive is full now, right? And they're asking you what? To pay. Yes. So you should know that, I mean, implementing or accepting or integrating AI systems also comes out with cost, right? Then interaction between humans and AI. Yeah, this is sometimes an issue. You sometimes when you're interacting with AI systems, I mean, yes, initially they will perform well, but as time goes on, you see that what they are telling you all things that are not there. That means it keeps on hallucinating. Then high quality labeled data set. This is something that anytime you want to build any AI or come with any AI project, the first thing you do is you have to make sure your data set you have it and it's high quality one, okay? Because your results will depend on your data sets. Your results will depend on your data sets. Okay. All right. Then balanced data sets. This is also another issue. Sometimes you are building a model, but you see that, for example, you are classifying between patients with tumor and patients without tumor. But you have a lot of data sets for patients without tumor. What about patients with tumor? T is less, so it's like imbalance. So if you should draw your bar chart, you see that one is like this, the other one is very small. Now, when it happens like that, you should expect the AI system to be biased towards this, because this one we have more data set than this, so the AI system will be biased. We have ways to curb that. I will explain it to you when we meet. Then amount of data from patients with the same disease is scarce. So sometimes, okay, the patient that you are dealing with, this patient is having this complication, right? It's only one data set that you can get from the person. You're not going to get it from anywhere again. So only one. That one, what are you going to do with it? Okay. Yes, although we have some AI systems known as few short learning that are people are researching into that to be able to help solve that issue, but scarcity of data, okay, is also another issue. Then, when your model overfits and underfits, I will explain this concept also to you. When you say your model is overfitting, also underfitting. So when it happens like that, it will incorrectly classify or fails to detect critical information. So these are all the challenges of adopting AI systems, okay, in clinical practice. All right. So I'll pause here. Any question?